degree. What's that?
Is that a 15?
Where? This? No, N is odd. Is.
Oh.
That's an S. Is.
Oh, we gotta write that one down too?
Yeah, you're gonna want that chart too. I guess I can add. No, I don't need that. We'll just quickly fill these out and you'll see that what we do today is pretty easy. Real quick, I know we've already talked about it, but they're gonna have you write your polynomials today in standard form. Remember what standard form means. Highest exponent first and work your way down, right? So when we put something in standard form, it's highest exponent first, work your way down. Is this in standard form? No. So to rewrite this problem so it's in standard form, I put my highest exponent first, and then I work my way down until I have no exponents. This is standard form, okay? So that's what they want you to do. Always put highest exponent first, work your way down. Now, I could classify this by its degree. I would say that this is quadratic, and I would call this a trinomial because it has 3 parts to it. So that's what this chart's going to do. It's first you're going to always put your equations in standard form if they're not, and then you're just going to label it by degree and by terms, okay? So here are degrees. We're only going to go up to 5 today. We're going to go up to 5 exponents, okay? If you have a degree of 0, in other words, that would be a degree of 0. You don't even have an exponent, right? So we don't have an exponent. We would call this a constant, or excuse me, we would call it constant, which means we have no variables at all. Okay? The name by terms, we would call this a monomial. Okay? Monomial means you have one term. Okay? And there's one term there. It's a 2. Okay, it doesn't have to have a variable. It's still a monomial. Okay, an example would be 2, 5, 7. Those are all just, they have no variables, right? And we would call that a monomial. Okay? If we have a degree of 1, that means we would call it linear. Linear. Okay? That means we have at least one exponent, or 1x, okay? I could call it a binomial, and a binomial means 2, like a bicycle, 2 terms. So this would be an example of a linear polynomial. Notice it's just 2x to the first, 2x to the first, and I have 2 terms, 2x plus 5. What separates your terms is your plus and minus. Like a lot of people, when they see a problem like this, they'll say, oh, that's a trinomial because it has 3 parts. No, this is a monomial. The only way that your terms come about is if you're separated by pluses and minuses. If I did this, then yes, this would be a trinomial. 1 part, 2 parts, 3 parts. 1, 2, 3. So what separates a polynomial by terms is the pluses and minuses. So this would just be a monomial. I don't have any pluses or minuses, it's just one term, okay? Make sense? If you have a 2, a degree of 2, we would say it's quadratic. Quadratic. It would look so, and we would call this one a trinomial. A trinomial. This would be an example of a quadratic trinomial. I have an x squared. Quadratic means 2. Quad. Okay? So that means 2. And now I would call this a trinomial because it has 3 parts to it. X squared, a 2x, and a 5. What would you say now? It would be a binomial, and is it still quadratic? Is it still quadratic? Sure. So notice that I could have a quadratic monomial, I could have a quadratic binomial, I could have a quadratic trinomial. Okay? You know, how many parts are there? Okay? 3 is cubic. We would refer to it as cubic. Cube means 3, so we call it cubic. Okay? Here's an example of a monomial, and again, it could be anything. 2x to the third. I would call that a cubic monomial. The highest exponent is 3, and it's a monomial because I only have one term. What would you say if I put a plus right there? 2 plus x to the third. It's a cubic binomial. Okay? All right. Next one, number 4. This would be quartic. Quartic. Quartic with an R. Quartic. Okay? Let me give you an example of a quartic binomial. There's only 3 of them. There's monomial, binomial, trinomial. We don't have anything for the 4th term or the 5th term. Okay? So here would be an example of a quartic binomial. 2 parts, and my highest exponent is 4. That would be a quartic binomial. Okay, last one, quintic. With an N, quintic. So you have quartic with 4, quintic with 5. Now, what happens if you have like more than 3 terms? Then it's called a polynomial. So if you have something more than 3 terms, we don't have a name for it, we just call it a polynomial. Okay, so here's an example. 2x to the 5th plus 3x to the 4th plus 2x squared minus x plus 1. I would call that a quintic polynomial. Highest exponent's 5, and it has 1, 2, 3, 4, 5. We don't have a name for anything above 4 when it comes to the terms. So I would just call it a polynomial. Okay? So here's all you guys are going to do today. They're going to give you a problem, like so. And they're going to ask you to write it in standard form. They're going to always tell you to put it in standard form. Okay? So when I look at this problem, the highest exponent is 6x to the third. So that's going to go first. Then my minus 4x squared goes next. And then my 3 goes last. So there it is in standard form. It's in proper form. Now, how would you classify this by degree? You would say it is cubic. It's got 3, an exponent of 3, and you would classify it as a trinomial. So I would say, here you go in standard form. I would call this cubic, and I would call it a trinomial. That's pretty much all you do today. Just put it in standard form, classify it by degree, classify it by term. Good? We're good with that? No need to see another one? All right, here's our last thing. Our last thing is this. You're going to kind of get into graphing, not today, but you're going to get into graphing any polynomial, whether it's x to the 4th, x to the 3rd, x squared, whatever it is. We're going to show you how to graph that. And sometimes your graphs look like this. Sometimes they look like this. Sometimes they can go like this, okay? And this is called in behavior. So in other words, what we want you to be able to do today is immediately look at a graph and just tell me what it's going to do in terms of its direction. Like for here, I would say up, up. It's both ends are going up, up. Here I would say down, up. Here you would say down, down. Okay? So in behavior just tells you what your graph looks like. Always read it left to right. Up, up. Down, up. Down, down. Make sense? So, don't worry about this. I know this looks pretty confusing. This is the formula on how to write something in standard form. Okay? Highest exponent first, then this would be one less. If this was a 4, this would be a 3. Okay? So in standard form, all it means is put your highest exponent, work your way down. To figure out in behavior of a graph, all you care about is the first number. That's all you look at. All of this other junk behind it, you don't care about. All we look at is just this part. Okay? So here's what I mean. I'm going to give you a problem like so. 4x to the 4th minus 6x third minus x. Okay, first off, is that in standard form? Is highest exponent first? Yes. Okay, let's just do this. What would you say this is? Just on my desk. You'd say what? It's quartic. You have 4 terms, or excuse me, a degree of 4. And how many terms do you have? 3. So you would say that this is a quartic trinomial. Now let's talk about in behavior. Okay, notice that A, this is your A value. Okay, N is the exponent. That's all you look at. That's all you look at. If A is positive, A is positive 4, and N is even, you have an even exponent, your graph is going to go up, up. It's going to look something like this. Or maybe it's going to look something like this. You have a graph that's going up and up. Okay? So if A is positive and an even exponent, up, up. Okay? If A is positive and N is odd, it goes down, up. If A is positive and N is odd, here's what I mean. If I change this to a 3, A is positive, N is odd. This graph is going to look something like this. It's going to look something like, it's going to go down and then come up like that. It's going to look something like that. Okay, that's what I mean by down, up. Down, up. Okay? If you have a problem like this, negative 2x squared minus 4x. You have a negative A value. That's what this means, negative A. And you have an even exponent. It goes down, down. I mean, you have a parabola that's going down, down. Left, down, down. Okay? And last scenario is if you have a negative and N is odd, it goes up, down. People like, I just can't memorize this. Just remember everything is opposites. If you know the first row, do you notice that these are the exact opposite? If A is positive and N is even, it's up, up. So now the next row is down, down. They're complete opposites. And notice that this is down, this is up. That's up, that's down. They're complete opposites. Okay? So, one quick example. What if I gave you this problem? And I told you to graph it. First off, let's work on classifying. Notice we have something to the 10th power. We don't have a name for degree of the 10th power. But what would you classify it by terms? Trinomial. You just say it's a trinomial. All right, so all you look at is this. The first number in front is a negative. So we know we're on this row right here. This is an even exponent. So that means that I follow this chart. N is even, down, down. This would be an example of a graph that's going down, down. And it might look something like this. X to the 10th power is crazy, but it might look something, you know, it might do something like that. But both ends of the graph are going down, down. Okay, make sense? So it's called in behavior. You just look at the first number and the exponent, and you just follow this chart. It tells you exactly what your graph's going to look like. Okay? Any questions? Everything's just reading charts today, right? Just reading charts. Pretty easy to do. Okay? All right, we are going to work out of the book, though. Working out of the book today. Okay? And I'll kind of go over it with you. So grab a book real fast while I kind of put it up here on the board. Pretty easy today.
I forgot you did wrestling until I saw the picture of you guys taking a group photo.
Yeah. Did you see my quote in the paper?
You
I
got
had
on
a
the
quote.
paper?
I had a quote in the paper.
Oh, look at you go.
Yeah.
You might have to drop one over there.
Yeah, there might be. There's some over there. All right, here's all you're doing. On 8 through 19. Maybe I'll break it up. On 8 through 19, I want you to put it in standard form. Then I want you to classify it by degree and then by terms. And I'll do number 8 with you so you know. Okay? And then on 20 through 31, I just want you to tell me your in behavior. Is it up, up? Is it down, down? That's it. And I can do number 20 with you. All right, so here's number 8. 7x plus 3x equals 5. Nope. 7x plus 3x plus 5. So they're not going to give it to you in standard form always. They want you to be able to put things in standard form. Is number 8 in standard form? How come? Yeah, can we add 7x and 3x together? We can add those together, so let's add them together. This would be 10x plus 5. This is now in standard form. That's in standard form. So if you can add like terms together, always add like terms together. That's a given. All right, so now just put a comma. Okay, what would you classify this by its degree? Is it constant, linear, quadratic, cubic, quartic, or quintic? This would be linear. It has a degree of 1, right? It has 1x. Remember, degree is this right there. If it has an x in it, it's got some type of degree. So I would call this linear. And then what would you classify it as? A monomial, binomial, or trinomial? A binomial. And I'm all right if you just say bi like that. Okay? So there you go. On number 8, I would say 10x plus 5. That's what it is in proper form. It's linear, because I have a degree of 1, and it's a binomial. Okay? So that's what you do on 8 through 19. Maybe we'll do one more. Here's 9. Is that in standard form, number 9? No. So what would it be in standard form? Negative 3x plus 5. Carry the negative with it. So this is in standard form now. It's ready to go. So what would you classify it by degree? Linear. And it is a binomial. There you go. That's all you do, 8 through 19. Put them in standard form, then classify by degree, or classify by degree, classify by terms. Okay? In a few minutes, I can do 20 with you, just so you can see 20. That's it. So it should take you just a few minutes to do this.